Welcome to Study Loop.
Let's go ahead and find the partial fraction decomposition for these functions in part A and B. In part A, we see that the numerator has degree that's equal to the denominator. They're both degree 6. And any time the numerator has degree greater than or equal to the denominator, we should go ahead and use long division, polynomial division. So we'll have a 1 up here, t6 plus t cubed. And then we have minus t cubed, and then bring down the 1. That's our remainder because t to the 6 does not go into t cubed. So in part A, we could go ahead and rewrite this as the quotient, which was 1 up from up here. Then we have our remainder, 1 minus t cubed, all divided by the original denominator. So now we could go ahead and use a partial fraction decomposition on this fraction. But I would always go ahead and factor out, definitely on the bottom, but it won't hurt to factor in the numerator because every now and then you may have cancellation. That will make the problem easier. So let's go ahead and factor this. This is just 1 minus t squared plus t plus 1. So this is just a difference of cubes, a cubed minus b cubed. There's a formula for that. A minus b, that was the 1 minus t. And then a squared plus ab plus b squared. And then on the denominator, we could go ahead and pull out a t cubed. And left over with t cubed plus 1. But this is a sum of cubes, t cubed plus 1 cubed. So there's a sum of cubes formula that you might recall. This time it's a plus b, and then a squared minus ab plus b squared. So we can go ahead and write this as t cubed, t plus 1, t squared minus t plus 1. And we see that there will be no cancellation here if you compare these circle terms. But at least we've simplified the denominator. What we should do here is check if this quadratic factors or not. Because if this factors, we need to factor it before we do partial fraction decomposition. So recall that if you have a polynomial, second degree quadratic, this will not factor if b squared minus 4ac is negative. In our problem, for this polynomial, we see that a and c are both 1. cb is minus 1. So plugging in a, b, and c into this inequality, we have 1 minus 4, and that's less than 0. So this means that this quadratic doesn't factor. So let's go ahead and rewrite this. This was our previous expression, and now this is all equal to 1 plus. And since there's no factorization and there was no cancellation, you could go ahead and just leave it as 1 minus t cubed if you like. Doesn't matter. We'll replace it in a moment. Then on the bottom, we have t cubed, t plus 1, and then t squared minus t plus 1. I'm running out of room here. Let me go on to the next page. Let me rewrite what I had. We had t cubed, t plus 1, t squared minus t plus 1. So that was after we factored the denominator. So now we look at the first term. We see t cubed there. This is what the book calls case 2, because we have a linear factor, t, that's being raised to the third power. So t is the linear factor there that's being cubed. So just for the t cubed, we'll have a over t, b over t squared, c over t cubed. And again, this a, b, and c is coming from the formula given for case 2. Then the next term, corresponding to t plus 1, this is just a case 1 term, non-repeated linear factor. So we'll have another constant over t plus 1. And then finally, this quadratic over here that did not factor. This is what the book calls case 3. And so we have ex plus f by the formula given in case 3. And sorry, that should not be an x up there. That should be a t, because that's our variable. So it should be a t there. Et plus f. And then we have our quadratic. So for part A, that's our partial fraction decomposition, and as the problem mentioned, it wasn't necessary to find the constants A all the way up to F, so we can stop right there. So let's box this. And let me go on to the next page here for part B. So we have x to the 5th plus 1, x squared minus x, x4, 2x squared plus 1 in the denominator as well. So looking at that first term, x squared minus x in the denominator, we should try to factor that. So there we can pull out x, and we'll have an x minus 1. Then for this term over here, although it's 4th degree, it's technically a quadratic in disguise. We can rewrite this as x squared plus 2x squared plus 1. Or if you want, let's replace x squared with another variable. This quadratic just becomes w squared plus 2w plus 1, which we know is just w plus 1, all in parentheses squared. And then going back to x, we can write it like this. So we have an x squared plus 1 squared down there. And our numerator is still just x to the 5th plus 1. We're almost done here. The last thing to do is to look at this quadratic that's being squared and see whether or not this thing factors. So just as before, we'll check the b squared minus 4ac condition. Here, b is 0. And then a and c are both 1. So this will just be minus 4. That's less than 0. This means that the quadratic does not factor into two linears. Okay, so let's go to the final answer. So taking this whole expression, the next line will be, well, the first term is x. So we just go to case 1 here. It's linear, and it's non-repeated. So we have a over x for case 1. Then here, still in case 1, it's another linear. It's different than the previous one, and it's non-repeated. So b over x minus 1. And then for the last term, x squared plus 1 squared, this is what the book will call case 4 because it's quadratic, doesn't factor, and it's repeated. So we'll have cx plus d over x squared plus 1. And because it's repeated, we'll need an extra term here, ex plus f over x squared plus 1 squared, and there's our final answer.